Now, there's another useful design pattern called the singleton. The singleton pattern, let's conceptualize it by thinking about yourself as an intern. You have a summer internship working at a tech company. You're tasked with specifically organizing some old paper files. But you happen to have 3 different managers. All have the same authority. No managers above the other, so all of them have the same amount of authority. But none of the managers actually know that the others have given you a task. Manager 1 tells you to organize your files by name, while Manager 2 tells you to organize the files by ID number. You can't really do by name and ID number. Manager 3 tells you to go to a coffee run. You can't organize any files if you're on a coffee run. These different managers have given you conflicting instructions. Because the different managers didn't work together, you now have 3 people telling you to do 3 different things. What would the best way be to solve the problem? Well, you could ask the managers to communicate before giving you your tasks. 1, they might get mad at you. 2, it takes time, right? All 3 of them have to meet first, and they don't want to waste the time by meeting to figure that out. That's annoying. The managers don't want to do that. So that's out. Then maybe the managers decide that Manager 1 is responsible for the interns, so that only Manager 1 connects and talks to the interns. So interns only have to listen to Manager 1. There wouldn't be any confusion what to do then. You also always know who to ask if you have any questions. Manager 1's your boss. What do the other 2 managers do? Well, they maybe don't exist. Maybe you don't have those managers anymore. Or maybe they're off doing something else completely. It doesn't matter. What matters is you know you have 1 manager, and that's the only person you needed to talk to. A singleton is kind of like this, where you create a single instance of a class and provide a global point of access to it. This is most commonly found in managers, things like a score manager or an audio manager. And the thing with singletons is that you get exactly 1 of that class, and you can only ever have 1. And it's global. Everything else in the system can access it. This is a way that you can ensure that you only ever have, say, 1 audio manager whose job is to play audio, or you only have 1 score manager whose job is to take track of the total number of points. Here's an example of an audio manager hierarchy. So you have the audio manager, right? Your audio manager owns the audio, but this point system, right, wants to trigger the audio manager to play a sound. Well, the audio manager owns it, so that actually belongs to the audio manager. And your combat system can connect to the audio manager to play a sword swinging sound or an enemy hit sound. Your movement system can connect with your audio manager to play a jump sound or a footstep sound. But because there's only ever 1 audio manager, every one of your other systems knows where to point, where to look. The perks of a singleton are that you can save some memory and performance by not having duplicated things. The instance also only gets created if you need it or use it. So if you don't ever play audio in your level, you don't ever load the audio. You can also be very flexible with your implementation. The manager is the one who handles the playing of the audio. So that means that the way that audio gets played only has to exist in there. The other classes, the other things, don't need to worry about it. Cons. You can cause some frame hitches if an instance is created at the wrong time. So there's some ways to protect against this, but let's say you're in the middle of a boss fight and you generate a new audio manager for the first time. That takes performance and that can cause some hitches. It can also be a little bit harder to pinpoint bugs because you have to connect to an extra set of files in order to play anything. And you're kind of just relying on that manager to work. The big one, though, is that it encourages coupling. You end up linking different things together that maybe you shouldn't. It's also not concurrency friendly, which means if you're working with threads on an online game, it can get a little wonky. But that's outside the scope of this class. Just know that singletons have perks, but they also have cons. At our level right now, they're fine to use. So here's a simple implementation. This is specifically in C++, but the basic structure applies anywhere. Where you have a class, right? A thing in your game, and you create a static instance reference to it. So static is the keyword here. So singleton will end up having a static reference to an instance, where if you access file system, it will give you back this instance of that file system. And it holds a private variable for that reference. So if you have a audio system, you'd create a static audio system instance. In this way, other files can say, well, audio system.instance.play coin pickup sound. So this is a singleton. And we'll work on implementing this a little bit later, but you'll probably encounter this one a fair bit, especially as you're learning to develop. There are other ways and perhaps better ways of handling this, but this design pattern is really useful to kind of, get things up and running. Next, we have the observer pattern. Think of it like a YouTube channel. So let's say you have a favorite musician and you love to watch their music videos. Every single time they come out with a song, watch it 5 times. Well, how do you ensure that you always get notified whenever they post a new video? Well, you hit that like and subscribe button, right? You subscribe and then you turn on notifications. You're subscribing to get a notification whenever the musician posts a new video. This is actually an implementation of the observer pattern. Let's say you're making a game and your game has coins that players can pick up. Every time you pick up a coin, 3 things should happen. Your player should get 100 points added to their score. It should play a sound effect. And then your player gets just a little bit of health back. So picking up 1 coin affects 3 different systems: your score system, your audio system, and your health system. Well, how do you make that happen? You could connect a player collision script that handles picking up coins with the score manager, audio manager, and health manager. But then all the different managers rely on each other. That's usually a bad thing. In a well-constructed program, your different files, objects, and classes should work independently of each other. As in, your audio manager should never need your player collision to run. It should just work independently. So you can sub them in, swap them out, you replace them, change them without breaking other things. It would be a bad way of connecting everything together. And unfortunately, this is kind of what the singleton pattern kind of encourages you to do. But we can counter that with a broadcast model. What if instead your player collision script broadcasts to whatever manager is listening, saying, hey, coin was picked up. This way, only the managers that are listening or subscribed are notified, and then everything else ignores it. The player collision script doesn't need to know or care what managers are listening. It just says, hey, I picked up a coin. Whoever is listening, great. Good for you. Just like when you subscribe to a musician or a creator on YouTube, they don't necessarily know or care that you subscribed. They just see that there is a subscriber, and they put things out for all of their subscribers and they broadcast that. That's the observer pattern. So if we have our audio manager, score manager, and health manager, if they're subscribed to whatever handles coins, right? They subscribe, then the coin manager can broadcast and say, hey, picked up a coin. And then the audio manager can hear that and then play a sound. Your score manager can hear that and add points. Your health manager can hear that and add health. Let's say you change your game design and you don't want to add health anymore. Okay, great. By changing one single line of code, you can just remove that connection and nothing else breaks. They're decoupled. Yes, your health manager has to know that there is a coin system, but it just holds a reference to it. And your coin system doesn't care what's subscribed. It's going to keep doing what it's going to do. So in the observer pattern, the subject has a list of pointers for observers. Your coin system is the subject, while your audio and score managers are the observers. Each observer gets a callback with when an event happens, specifically like picked up coin. When the event is triggered, the subject will loop through a list calling all of the callbacks. So it will broadcast. It says, goes through its list of whoever subscribed and tells it, hey, I picked up a coin. Hey, I picked up a coin. Hey, I picked up a coin. The subject doesn't have to know anything about the observers, nor does it have to know anything about how many there are. it will just kind of operate independently of what is subscribed. Even if nothing's subscribed, it's still going to broadcast, even if no one's listening. The observer also adds itself. The observer subscribes to the subject list. The subject, your coin manager in this case, doesn't need to know about the audio manager at all. The observer, your other managers, the listeners, they subscribe themselves, listening for that event. Now, implementing this is different in each game engine. Luckily, all modern game engines basically have tools for implementing the observer pattern. It does differ based on the engine, though. The idea remains the same.